Hey class, in this video we'll be talking about 3D graphics and using a new library, the three.js library. We'll go over creating a simple scene using some basics of 3D rendering and go over the basic syntax and installing the library. So to get started, I'm gonna create a new project and then we'll take a look at the three.js library. So I'm gonna make sure I'm on my MMP 310 repository. I'm going to click Show in Finder. I'm just going to make a new project here. So this is project 3, and I'm going to do this as 3-1. So if I make more versions of it, that'll be easy. And I'm not going to add anything here. So we'll be adding some stuff from scratch based on the three.js website, some tutorials that they have there. So I'm going to open up 310 in Sublime Text. So I have that ready to go. And then let's take a look at the three.js library. So I'm going to open up a Chrome window and just go to 3js.org. And so there's a lot of similarities and differences between 3JS and P5, which we used in our earlier projects in the class. There's also some things that are similar with the quiz project that we did for the second project. So it'll be a good chance to kind of triangulate or see 3 different versions of using JavaScript for a project. In each case, we can kind of think of the logic of our program as being separate from the renderer. Both 3JS and P5 use the canvas as a renderer as opposed to the regular HTML document. And our quiz project just uses HTML and CSS as what we can call the renderer. So we'll talk about that a little bit more in 3JS. We actually have an object called the renderer, so I'll talk about that a little bit more once we get to that. And we'll talk about some of the differences between 3D rendering versus 2D rendering. But let's first just look at the 3JS website. So it's a really nice website. It's similar to the P5 website in that it contains documentation and examples. On the front page, there's a whole bunch of examples of projects that people have done using 3JS. Let's look at a couple of these just to get a sense of the different things that are possible. So I'm just going to choose a couple. This looks kind of interesting. So this is a 3D interactive experience that goes along with an opera production. So you can see the lighting that they're using, some of the 3D objects. There's also this sort of interactive little light that we can move around. So a lot of particles happening. Experience kind of goes along with the music. So there's a lot going on in the scene, but still being rendered in the browser in real time. And ultimately, it's actually using quite simple elements. It's just combining them in a complex way. So let's look at one more scene. There's a lot of lighting here. We probably won't talk too much about lighting in this video, but we'll get into it in a later video. So that was cool. Let's take a look at another example. This is the one that I think I showed in class previously. And this is a website, it's sort of a portfolio website, using 3JS as kind of an interface. So it's got these different physics and animations with this car, and even some audio. You can hear the car. It's making sound, but then we can kind of see some projects that the developer has worked on, and we can actually interact with them. So it's kind of behaving like a normal website, but it's just being rendered in 3D. So if I go in here and hit enter, it opens up a project that the developer did. So that's a fun way to make like an interactive portfolio that's kind of like a little game. There's more game-like examples. This one is a sort of Frogger style game called Crossy Road. So using some pretty basic shapes and stuff, but also uses physics and interaction. Let's take a look at a couple more. So this is an interactive animation. Actually, I'm not sure that, oh, it is interactive. So I have to put these pieces together on this sort of like robot character. Again, it's using pretty simple shapes and geometry, but it's combining them to a nice effect. It's got a nice animation. And so it's also real-time rendering. To make it interactive, it has to be rendered in real time. So now I can click this little switch. Nice little animation. Actually can't really change the camera at all, so it's a fixed camera. Yeah, so most of this is just a narrative animation with some interactive components, and it's in Korean, so I actually don't know what it's about. But it's a cute character. It's a nice animation. So it's really using a lot of simple shapes and stuff, which is nice. So let's look at one more example. This is one that I always like. This is just kind of a goofy dance party website with a few different characters. And so it's interactive, so I can change how much they're dancing and various aspects. So in some ways this is kind of like a demo of how this works. Oh, and I can move the character around as well. It's pretty fun. You can change the background color as well. So that's pretty fun. So just a few different examples of things that we could render in 3D using three.js. Let's look at a couple more things on their website. So they have a really good documentation where it has everything that you need to use anything that the library does. We're actually going to start with this tutorial when we first start creating our project, but you can search anything in here. So if you want to learn how to make a box, for example, you can just type in box and it'll show you box geometry, and some of them have interactive examples and then some code. So it's very useful, especially with 3D. It's kind of hard to get started. So there's a lot that it will help you do. We can look up materials. You can look up effects, effect composer, and look up different examples. So the documentation is really easy to use. There's also a lot of examples which you can scroll through and see how different stuff looks and try different things. And then you can also search stuff in here. So like if I wanted to do an animation, I can type in animation and then we'll see everything that's just limited to animation. So there's a lot of useful stuff in the docs and the examples. There's one more thing here, which is the editor, which is a relatively new tool. It's a little bit like the P5 editor, web editor. It's a good way for us to look at how a 3D environment works. So let's talk a little bit about the differences in 3D. So obviously we're only just adding an extra dimension here, but it adds a lot of complexity for various reasons. So let's talk about some of those. We won't look at everything in the video today, but we'll cover them over the next couple of videos. So when we're working with 2D, and specifically when we're working in P5, we're using a canvas. And we have two dimensions. We have the x-axis, which goes this way, and we have the y-axis that goes this way. And so when we describe where something is in space, we give it an xy value. So however far it is from the left side of the canvas and however far from the top of the canvas is. So if we want to draw an ellipse, we would make a point and then we draw the ellipse. If we wanted to draw a rectangle, we'd say this is the origin of the rectangle. Then we draw a rectangle. Same thing with like images or other shapes and things like that. When we're looking at a 2D image, we can create things like perspective by making things larger or smaller. But typically, especially with the projects we've been doing in class, we haven't really thought a lot about like depth or if something is far away. And we also don't think a lot about the fact that there's a perspective on the image. We kind of think of it as just a flat image, and the relationship between the viewer and the image is implied by the fact that it's a 2D surface. So when we're looking at a computer, which the browser is on, you know, we just have a 2D surface, and typically the person who is looking at it is right here, and they're just looking directly at it. So it's kind of implied that we're just looking at a flat surface. When we talk about rendering in 3D, there's this sort of illusion of depth that's created by the renderer. And so even though we are still just looking at a 2D surface, we have to behave as though we're looking at a 3D surface. And that changes a lot in terms of how we consider how to render shapes and colors and objects on the screen. So obviously with three.js, we no longer have this XY concept. We still have the X axis and the Y axis. So we can think of like X going horizontal and Y going vertical. In three.js, Y is going to be probably what you're used to in math, which is the Cartesian coordinate system, where Y is positive as it goes up, as opposed to in P5 where Y is positive going down. So X is positive going to the right, and then Z is this new axis that's actually coming directly towards us. And so Z is positive coming basically out of the screen. So if we imagine, here's our computer. That's a pretty bad computer drawing, but just imagine this is our computer, and here's us. Here's our eyeball, and we're looking like that. So now Z is basically like coming towards us. Obviously, it's not really moving towards us in space because the computer is still a flat surface. But the Z dimension is the illusion of depth. So Z is positive as it comes forward towards us and negative as it goes away from us. So that's kind of the main difference with the 3D objects, is if I want to put something in space in 3D, not only do I have to position it, let's say it's 10 on X and 10 on Y, it might also be like 10 on Z. And so it becomes a lot harder to tell where things are, and we'll go through a few examples of that unless you can change your perspective. So when we're working in 3D, we're going to have to change our perspective. And so the way that we think about that is what's called a camera. And so with 3D, we no longer have this implied perspective of the 2D. We have a perspective that can change. And so if we have, here's our space, we now have our camera. And so our camera is like this whole other thing where it has directionality and position. So if we have like a cube right here, if our camera is looking directly at that cube, it's just going to look like a square. Okay, if our camera is up here and it's looking down at the cube, then we're going to be able to see the top of the cube like that, as well as some of the front of the cube. If it's looking up at the cube, we'll see the opposite of that. And then if we're moving to the right or the left, then that's when you start to see like the edge of the cube like this. If we move the camera over to the right or over to the left. So the angle and the position of the camera matter as well. If the camera is very close to the cube, it's going to get much bigger. So if we move the camera like up to here, it's going to be much larger. If we move the camera way back here, then the cube gets smaller. Okay, so in programming, we're just kind of trying to recreate the way physics and perspective works in real life. We also now have to consider more of the geometry. We're no longer working with just a flat plane. So with a plane, we just have basically X and Y, or a circle. We have the radius of the circle and it goes around. With 3D shapes, now we have an extra dimension, which actually adds a lot to it, right? We have, to a cube, we actually have 6 different sides. There's the front, the back, it's back here, here's the top, there's a bottom, there's a left, and there's a right. With a sphere, it kind of looks like a circle because it's even. It has a radius, so it's even on all sides, but it can still change depending on our perspective on the sphere. And then, of course, with the other geometries, things get more complicated. So with a rectangle, we really only have to think about 1, 2, 3, 4 different points. With a cube, we have to think about 1, 2, 3, 4, 5, 6, 7, 8 different points that make up that cube. With a rectangle, we only have one plane, right? It's right here. With a cube, we have 6 planes that we have to worry about. And with a rectangle, we only have 1, 2, 3, 4 edges. With a cube, we have 1, 2, 3, 4, 5, 6, 7, 8 in the back, and then 9, 10, 11, and 12 edges. So with 3D geometries, we really have a much higher level of complexity. We never really think about like vertexes and edges and faces when it comes to a regular 2D rectangle. But with a cube, we now have all this extra data that we have to consider. The last bit that makes 3D complicated, which we won't get into too much in this video, is lighting. So if we have a sphere, if there's no lighting at all, then the sphere will just be dark. It won't be visible. If we have lighting, then we'll have a certain color. If we have lighting coming from a direction, then we'll have, you know, more light over here and less light sort of at the back of the cube. And if we have a light that's a different color, then we'll add the color of the light to the color of the object. There's a lot more things to think about when it comes to 3D rendering, and we're recreating that stuff in code. So three.js just kind of like does its best to recreate how things look in reality, but it adds a lot of complexity. So there's a lot of things to cover, and one of the things that I've found working with three.js, it's a very good implementation of 3D rendering, but there's a lot of cases where you might forget, something might disappear and you don't really know why. So there's a lot of things to look out for. So today we're just going to make a simple scene. We're going to do it in code, but first I want to show the editor, and later on I'll actually show you if you make something in the editor, you can actually export it and load it into your own scene. So you can either make stuff using code, or you could actually make stuff using the editor and then add it to your own scene if you prefer to work that way. So let's just go over stuff in the editor as a way to kind of look at the properties of a 3D renderer. You can see immediately that I can actually change the perspective of my scene. I'm clicking on the left button on the mouse and just moving it left and right to rotate around the y-axis. If I go up and down, I'm rotating it along either the x, or if I rotate around, the z-axis. And you can actually see the axes down here. And the nice thing about this little widget in the bottom right is that you can see the positive versus negative directions. So with the Y label, that's the positive, and then the green dot at the bottom is negative. Same with the X and the Z. So right now we can see that Z is pointing towards us, X is pointing to the right, and Y is pointing up, which is the default. So we also have like a scene view over here, which right now it just has our main scene and our camera. The camera is kind of where we're looking from. And we can add new cameras, but there's just kind of a default camera stuck in here. The scene is how three.js sort of organizes the objects that it needs to render. So everything has to be part of a scene for that scene to be rendered. And so if you look at the widget as I'm moving the scene around, you can kind of see what our current orientation is. So then if we click on the scene, you can see there's a few things. There's a position, a rotation, and the scale. So you can edit those things for any of the objects. There's also a geometry and a material. So let's actually add an object to our scene. So if we go to add and we add a box, it's going to add a little box to the middle of the scene. I can also zoom in and out on the scene using the mouse wheel. If you don't have a mouse wheel, you can use whatever the scrolling gesture is on your device. And you can see that with our box, we can see kind of the different faces of the cube. Right now its default is black. It's wireframe, so we can see the geometry, but that's not always the case. And there's these little arrows poking out of it that highlight when we hover over them that are object manipulators. So right now it's set to the position, which is this like little arrow icon up here. So I can move the position. And if you look at the position values over here, as I do that, you can see that they're updating. So we can actually edit the position here. If I say it's like 5, it'll disappear, but it's really just over here. So you do have to be careful with the camera perspective there. And so you can see those values changing as I move the box around. We can also change to rotation. So we can rotate on the different axes. And you can see the rotation happening here as well. And the nice thing is this is kind of interactive, so I can move these up and down. And then finally we have the scale. So we can scale the whole thing, or we can scale each individual dimension. So that's a box. So we have the geometry. We can actually change the geometry as well, which is different than the scale. The basic geometry is then multiplied by the scale. We can also change the material. So there's a lot of different properties for the material. We won't go over them in too much depth today, just because we are going to kind of skip over that because it gets a lot more complicated. So we'll do another video for that. You will notice that if I change the color, nothing really happens because there's no lighting in the scene. So with color in a 3D environment, it usually has to reflect light, but we can either change the type of material. So for example, if I use a mesh basic material, now it doesn't care about lighting if it's just a basic material, so I can set it to whatever color I like. If I stick with the default Lambert material, I can actually change the emissive color, which makes it a sort of a light. So it'll actually cast light out of it. But I'll probably just stick with basic materials for today. So let's look at a few of the other things we can add to the scene before we move into our code. So if I go to add, that's a box. We also have a circle, which is actually just a 2D object. So if we turn it around, it's invisible on the other side. So that's another thing about 3D objects is they only actually render on one side. I think you might be able to set, yeah, so in the material you can actually set it to be double-sided. So then you can see it on both sides. But the default is going to be front. So you only see it on the front. And so with a circle, with that geometry, we can actually increase the number of segments in the circle to give it more detail. So if we have very few segments, it's going to eventually just be like a triangle. And if we add lots and lots of segments, then we get a smoother circle. And then of course we just have the radius to make it bigger or smaller. The dodecahedron is a 12-sided object. We can increase the level of detail there as well to get closer to like a sphere object. Icosahedron is another way of creating basically a sphere. And again, if we increase the detail, we eventually get towards more of a sphere-like object, but it's basically just a sphere. Same thing with the octahedron. So these are just kind of like different geometries that have a radius. Then we also have the sphere itself, which has a radius, how big it is, and then the number of segments and the height segments. So we can add more details there. And in a 3D scene, the more detail you add, the harder it is, or the longer it takes to render the scene. Obviously, it's not having any issues here. It's not slowing down because we don't have that much geometry, but you do have to be careful. I just started a new scene to clean that up a little bit. So here's our torus. It's basically like a donut. It doesn't look like one right now because we don't have a lot of segments, but if we add more segments, you'll see it starts to look more like a donut. You can also change the radius, which is the inside, and the width of the tube, which is obviously the width of the sort of donut part. We can also use a cylinder, which is like a circle with some depth. So there's a height to the cylinder, and then there's the size of the radius on the top and the bottom. So we can make a cone if we make the bottom very small, and then we can also change the number of segments to make more detail as well. So those are some of our basic shapes. There's also some lighting and different things in there that we're going to kind of skip for now, but the editor is very useful. I'm going to go into the code for a while, but we'll come back to this later. So I'm just going to leave, I'm going to go to new here and hit OK. So let's actually build out our scene in our own code. I'm going to go back to the three.js website and go to the documentation and go to getting started. So I'm just going to go over how to set up the scene, and they have some good examples that we can just use. And I'll talk about what everything is doing. I'm not going to cover every single aspect of this part, but we'll cover the things that we need to get our project started. So it's nice that they actually have some HTML for us to create our HTML site. So I'm going to copy and paste this HTML and then paste that into Sublime, make this a little bit bigger, and save as. So I'm going to save this as my project 3-1. This is going to be index.html. And you can see that three.js wants us to write our JavaScript directly into the HTML page. Typically, that's not what I like to do. So instead of doing that, I'm just going to delete this and add a little source here. And so we'll call this scene.js because we're just going to be building a really simple scene today, going over some basics. So this is scene.js, and we'll make that JavaScript file in a second. And then, of course, we need this JavaScript, this three.js library. So they have a link to the library here. You can see it's 3js.org/build/3.js. There's also three.min.js. So if you want to download that version of the library, feel free to do that. I'm going to save this and just make sure I'm in my project 3-1 folder, and save as three.min.js. And then they actually suggest having a JS folder because we are going to have to add at least one more JavaScript file. So I'm going to make a JS folder there and save the three.min.js. It doesn't make a big difference which one you use. The three.min.js obviously is going to have a lower file size. So since we'll be uploading it to GitHub eventually, that'll just make that a tiny bit faster. Now we can see that I have the three.min.js here. I'm going to add in .min.js. They also have their CSS written directly into the HTML. You can see that basically they did what we did in one of our P5 examples, which is to take out the margin for the body and to change the canvas display to be block. So for a three.js project, even though there's no canvas here, the library is actually going to create a canvas just like P5 does on the HTML document, which is going to be used to render our 3D scene. So let's open this up. I'm going to start the Sublime server and go to localhost 8080. And I'm just going to type this in. So this is project 3-1. And so we don't see anything yet because we haven't added any code yet. So let's go back to our creating a scene. And so they basically give us the main things that we need to create our scene. So the first thing that we need is the scene itself. So I'm going to copy this over and I'm going to create my new file and save as. So this one is just going to be in my main folder. I'm going to call this scene.js. And so I'm going to paste this in here. So let's talk about what this means. Constant scene gets new 3.scene. Okay, so some of this probably looks familiar, some of it probably looks different. Constant, we learned in our last project, is a constant variable. So we're not going to reassign the scene to anything. So we don't need to use var or let here. We can just use const. Scene is the variable name that we're going to use for the scene. We're assigning it. The 3.scene is an object, so we're using new to instantiate a new object. So we talked about that when we were talking about classes. And then the reason 3 in capital letters is appended here is because that's a convention of the library. Everything in 3.js is part of this gigantic 3 object. So if we go to the console and type in all caps 3, you can see there's a ton of different properties and methods here, and everything that we can do in 3.js is inside of this 3 object. The reason they do that is to avoid having like a million functions and properties that are part of the global scope. P5 avoids this by limiting the number of functions and properties that are globally defined, but it does represent 2 different programming philosophies. In JavaScript, we want generally to keep things out of the global scope so that we don't have multiple variables defined in the same way. So one of the things that you probably have noticed with P5 is if you're trying to make like a color and you want to name it red, you're going to run into an issue because there's already a function called red. 3.js avoids that by putting all of their methods and properties inside of the 3 objects. So things like, P5.ellipse, or things like the ellipse, the rectangle, the background, all that stuff in P5 is now in 3.js, it's going to be 3.ellipse or 3. Whatever. So everything is inside of this big 3 object. It makes it a little bit longer to write, so we have to type the big large 3 every time. And they actually have updated it to work slightly differently, but we're going to use this because it's more familiar to us. And then everything always starts with 3 and then dot and then whatever the object or class name is. So this is our scene. Scene is basically just a way of organizing like what we actually want to render, and we'll see how that works when we get down to the renderer. So we start with the scene. That's one of the main things we need. Then we have a camera. So remember, we always have to have a camera because we have to know where we are standing and where we're looking inside of the scene in order to know how we actually see stuff. So I'm just going to copy and paste here. This is a very standard perspective camera. Perspective just means that it represents 3D in like a perspective based way as opposed to orthographic. So orthographic will just show like a flat scene where nothing has a different size depending on how far away it is from the camera. In perspective, something that's farther away from the camera is going to be smaller, and something that's closer to the camera is going to be larger. So that's how we see in real life, and the perspective camera tries to recreate that. The orthographic camera is useful for doing things like blueprints or architectural design, because we can see how we see the actual absolute height and size of things. And some games are also built in orthographic view, like that Frogger style game that we looked at a moment ago was in orthographic view. So then finally we have the renderer. And the renderer is just kind of like a fancy word for the thing that draws. Like if you think about drawing, usually you say you like render, maybe more in like a more technical setting, like in architecture or something, like you do a rendering of a building or a rendering of a tree. A renderer is just something that draws something. The WebGL renderer is something that draws something in 3D. And so this is essentially like what our draw function is doing in P5, but we have a little bit more direct access to the renderer. We have to do a little bit more to set it up, and then we have a bit more control over it. And so I'm going to copy the renderer. That's our WebGL renderer. And then we can set the size. So render.setSize, we're just setting how big it is, basically the canvas. So we're using window.innerWidth, which is just like a DOM thing to get the width of the browser, and window.innerHeight to get the height of the browser. So it's going to fill the whole browser. And then we're actually going to append the DOM element, which is a canvas of the renderer, to the document. So in P5, it does this for us. In our quiz function, in our quiz project, we did all of that ourselves using append child. So we're familiar with that. In three.js, they don't do that for us. We have to do it ourselves. So now we have our renderer. If we go over to elements, you can see basically inside the body, three.js has added a canvas, and you can see that the width and the height match the width and the height of the canvas. So if I reload this, the width gets bigger, and the height stays the same because I just made it a little bit wider. So you can also see that the renderer has a black background. That's kind of the default here. If we change the background of the canvas, you won't be able to actually see that. So if I say, for example, like the background of the canvas is blue, it's still going to be black. One thing that we could do to change that is we can set transparent to true. So for example, if I add some options here and I say transparent, or maybe it's alpha, let me look this up. Renderer, WebGL renderer, let's see. So in the documentation, you'll see the constructor, which is like the main object. That's sort of like our scene class or our game object class. And then there's some properties. So alpha. Okay, so it's actually called alpha, whether or not the canvas contains alpha. So we can say alpha is true. Load this again. And now if I say the canvas background is blue, then we'll actually see that background. So we can use that for today. Later on, there's other ways to change the background of the scene using three.js with like a material or something like that. But that means we have to render it. So that takes up processor time. If we just set the canvas color, then it'll do it in CSS. And we can even set it as a gradient. Like if I wanted to do maybe like a linear gradient for the background, maybe from like blue to light blue. That might look kind of nice. So we can use that as a background to start. And having a background with some different color going on in it will actually be kind of helpful. So let's add that to our CSS. We can always take it out later, but it'll help us kind of distinguish the geometry a bit because we're not going to be using lighting quite yet. So just a couple things to watch out for. So one thing you might be wondering about as well is that why did I put these like spaces between the first argument and the last argument? This is a convention of three.js. You can see that they use this in the code that they added, and they also want you to use it as you're writing your code. This is really just like a preference, and as far as style, it makes it a little bit easier to read things, and it follows the convention where we put a space after a comma. So I'll try to use that as I'm doing it. It is just kind of like the preferences of the people who created three.js. And so all of the examples use that. And if you're a little bit finicky like I am, that means that you'll want to write your code to match it so that you don't have kind of mismatching code in different places. But it doesn't actually change the functionality. Okay, so that's a lot to cover, but we're actually getting quite close to creating a scene. So we've got our renderer. And so now we're going to add our first object here. Okay, so with any 3D object, we have basically two components. We have the geometry and the material. You can think of the geometry as just like the points of the object, like the cube. If you're thinking about a more complex object like a person, it's just like the thing, it's just like the 3D sort of space that a volume takes up, that a thing takes up. The material is more like the surface of the geometry or the object. So you can think of a material as kind of like a t-shirt. It has like a basic color, and then it also has some properties of how it interacts with light. Like some t-shirts don't reflect light, other t-shirts like maybe like a running t-shirt or something like that are more reflective. But we won't worry about that too much today. We're just going to think of the material as a color. So it's just like the thing that is on the surface of the geometry. And when we put those together, what we call it in three.js is a mesh. So a mesh is just a combination of those things. And then, so let's make some geometry real quick. This will just be our example. So we have constant geometry. And so again, we have to use the new keyword because we're creating these new objects. So to make a box, we use three.boxGeometry. And then with the box geometry, there's a bunch of parameters. You can see they didn't fill in any of those parameters. So you don't have to fill in the parameters if you just want like a default box. So let's leave that alone for now. But there are more parameters. So if we click on this, I guess I can't click directly on that. Let's look up box geometry. So if we look at box geometry, you can see there's a few parameters here, and then you can see there's a whole bunch more parameters right here. So we'll go over those a little bit later. So let's go back to where we were. Okay, so we have our geometry, which is basically just the 6 faces that make up a cube. And then we have a material. So we have constant material is new 3 dot, and we're just going to use a mesh basic material here. There's a lot of different types of materials. This basic material essentially means that we don't need to worry about lighting. We can just give it a color. So I'm going to give it a color. Again, I'm adding these sort of options here. So if for some things you can add arguments like just 1, 2, 3 like that. In a lot of more complex things, we add arguments inside of these curly brackets because some of the arguments have defaults. And so we can just add just the arguments that we want. So for here, we're just gonna add a color. Another thing that's a little bit weird about three.js is that they use actual hex values for the colors rather than strings that represent hex values like they do in P5 and CSS. So it's the exact same thing as the hex value that we're used to with CSS, except now it's an actual hex value, and we know that because it's not in quotation marks. It's just a number, but it's a different representation of a number than 1, 2, 3, or 0.5 or whatever. But it still matches our hex values. So for example, if I go to HTML color codes and I just choose a color here, let's choose a nice, well, we have a blue background, so let's choose something that'll go against that. So let's get a purple color here. And so if I just copy this hash here, or hex value, it's going to work the same way. I just have to put 0x in front of it. So this is a 0, and this is an x, lowercase x, and then there's our typical hash value. So we'll see that in a moment when we load our scene. Finally, we have our mesh. So it is a bit complicated because there's 3 parts, but we are working in 3D. So finally, we have our box, which is a new mesh. So we say new 3.mesh, and that has the geometry as the first argument and the material as the second argument. And you might be thinking, can I just put this directly right here? Do I have to assign it to a variable? You can put this directly in right here. It just makes the lines very long. And then you also wouldn't be able to like reuse this geometry, which might be useful. And so then finally, we just add the box to our scene. So we say scene.add, and then we add our box. So we're not gonna see anything quite yet. I'm gonna skip this line for now. So we still don't have the box because we're not actually rendering our scene yet. So let's render our scene. So to render the scene, we can actually just say render.render. So let's do that first, and then we'll talk about what's called the animation loop. So I'm just going to copy this first. I'm going to say render.render. And so the render is the thing that draws the scene. Render is just the method that is going to do that. The scene is the collection of objects that we want to draw, and the camera is the perspective from which we're looking at them. When I render the scene, we're not going to see anything. And that's because of this line right here. So I just want to go over this because this is something that you'll run into a lot as you first start to work with 3D. You're saying, I made this box, I added it to the scene, I added material, I did everything I was supposed to do. Why don't I see anything? Well, right now, here, if we look at what the scene looks like, here's our box, okay? And the box position is in the origin, which is 0, 0, 0, right? X, Y, and Z. And here's our camera, okay? Also at 0, 0, X, Y, and Z. And so the camera is actually inside of the box. And with meshes, there's no material on the inside. It's only on the outside for light to bounce off of. So the camera is basically looking out the back of the box. So how do we fix that? We move the camera. So that's what that other scene was. I'm going to put this up here next to our camera. I'm going to say camera.position.set. Okay, so we set the position of the camera. The default position is 0, 0, 0 for any object in the scene. And what we want to do is if our box is right here, let's say this is Y and this is Z, and our camera is right here, what we want to do is we want to pull the camera back so that's in the positive direction. So we're going to say camera.set position X, Y, Z. Let's say Z is 5. There's our box. Okay, now if we move the camera on X, because it's a perspective camera, we start to see a different position of the box. So we can see that perspective. So let's move our camera back a little bit. We can also move the camera up a little bit on Y. Now we don't see the box. There's a really nice way to fix that. We can say camera.look at box.position. Okay, so since the box is in the middle of the scene, now we're gonna look down a little bit. Okay, so in this case, we've just rendered one image, basically. So nothing's gonna change, like we can't do animation, we can't move around. And that's sort of like if you just drew something in P5 in the setup function and then never called the draw function. So the next part and the last part of this kind of tutorial that we're gonna look at is called the animate loop or the animate function. So basically, we're gonna call animate, which is gonna call this function, and then it's gonna request an animation frame, and then it's gonna call itself again. And this is actually exactly how the P5 draw function works, except we don't have to build it. It's done by P5 library itself. Essentially what this is saying is to draw a scene, and then draw the scene as soon as you're ready to draw it again. Request animation frame is a global JavaScript function that basically tells the browser to draw on the canvas, but wait, the canvas has, the way that JavaScript works, it's a bit complicated, but basically there's like a specific point at which it is set up to draw a new canvas that's kind of optimized for drawing. And when we say request animation frame, instead of just saying draw this as soon as you can, we're saying draw this the next time you want to render an animation frame. So that's going to make our animation run a bit more smoothly. To do that, we're just going to create a new function called animate, and we're going to render the scene, and then we're going to ask to animate again. And so it's basically a function that's constantly calling itself. So it's going to be running as fast as the browser can run. And then we just call animate to get it started. Okay, so now it's actually animating, but we can't see anything. So let's add some animation. And they give a very simple example, which is we're just gonna rotate this cube on the x-axis first. So let's copy this in here. So anything that you wanna animate should go in the animate function. It's basically like the draw function for P5, but in three.js. So let's take our box, let's take the rotation on X, and let's just increment it a tiny little bit each frame. So it's gonna start moving. So you can see it's moving, it's animating towards us. This is a little bit tricky to get used to. The x-axis goes like this way. And so if you rotate around the x-axis, that's kind of why it looks like it's rotating towards us. So then we can also say box.rotation.y plus equals 0.1. And so now we're rotating in two directions. It's actually quite fast, so let's make this even slower. Okay, so that's a little bit easier. And we can tell it's a box because we can see the edges of it, but because we haven't added lighting or anything like that, it looks very strange. Like it's very distorted in some cases. It looks quite weird. So that's what we'll be doing in a later video. For now, we're just gonna be focusing on the basic different geometries, the perspective and the positioning in the scene. So we'll just add one more thing before we start drawing our scene. So with our current scene here, the camera is kind of like stuck in one place. Like we can't move back and forth, we can't move left and right. And when we're building a scene, that can be tricky because we're going to want to move around to change the perspective so we can see the 3D geometry. So with three.js, there's a bunch of different ways to control the scene. If we go to examples and go to controls, we can see a few of these. So there's the orbit control where you move around sort of a center position, and you can move up and down, and you can move left and right, zoom in and zoom out. It's the same as what is default in the three.js editor. So that's what we'll use. There's other controls. For example, what's called pointer lock controls is sort of like what you would use maybe in a first-person video game where you're moving around. And these are scripts that other people have already written because they're very common, so it's nice that we don't have to write these for ourselves. There's also trackball controls where we kind of move around in space a little more quickly. And there's also fly controls where we're kind of flying around the screen so we can move in and move out of a scene, and we can kind of use the mouse to go one way or the other. So those are a few basic controls, and one of the things that will be good to look at as far as using our orbit controls is how to actually add something like this to the scene. Usually in the examples, there's a little icon with the two brackets here, and if you open that up, you'll be able to see how to get orbit controls. This is done using the module system, which is the new system that three.js uses. We're not going to be using that system, at least not when we're first learning how to do it. So if you see something that says script type module and some syntax like this, just ignore that one, but keep in mind what is needed because we can get the non-module version of the orbit controls from the GitHub. Another place that you'll see scripts is if we were actually looking at the documentation and I went to controls and went to orbit controls. Usually somewhere at the bottom, there'll be a link. And so we can see the source comes from examples/JSM/orbit controls. And so you can see right here where it says JSM, that's the model. That is the module version. We don't want that. So what we can do, there's a couple ways to do this. One is I can just go back to examples and click on JS instead. Go to controls and then find the orbit controls. If you get linked to a module version, you can also just change the link up here from JSM to JS, and that should bring us to the orbit controls. So that is one sort of tricky thing about developing with three.js is that they've adopted this new module-based version, which is a new JavaScript thing that wasn't previously available. And it is a useful way to develop, but it requires a little bit more explanation. So since we're just going into this library for a couple of weeks, I'm not going to spend a lot of time working on that. So let's go to examples. And the GitHub is organized in a way that is a little confusing because there's like a ton of files in here, but basically it's all the examples that you see inside of this examples, inside of the examples page here. So they're all just in this one examples folder, and then these are all just files to host them, and then the JavaScript is all in here. So since we're looking for orbit controls, that's under the, first we go into JavaScript, and then we go into controls here, and then click on orbit controls, and then we want to download this, so I'm just going to click on raw, and then do Command S to save as, and we can put this also in the JavaScript folder. So just make sure we're in project 3-1, and go in JS and save as. As usual, when we're adding JavaScript to a new project, we have to go back to index.html and add a new script file. So I'm just going to copy this script and paste it. And then this one is called orbit controls. You'll notice that the file name uses capital O and capital C for orbit controls because it is an object that is getting added. So it's a little bit like adding our class syntax. So now that we've got the orbit controls, we need to add them. So let's look at the example in the documentation for how that's done. So I'm going to type in orbit controls, click on orbit controls, and so we can see where it adds the controls here. So it just creates a new orbit controls object. It really does a lot of work for us, which is really nice. It takes the camera as the first argument, and then the canvas, which is render.dom element that refers to the canvas as the second element. And then if we want to update the controls, we use controls.update. So I'm going to copy this and I'll paste it. Doesn't really matter where this goes, although it does reference the DOM element, so that needs to exist. So let's put it under our renderer. So this won't work unless we actually call the update function. So, and I got an orbit controls is not defined. So let's just double check that I spelled this correctly. Oh, actually, you know what I did wrong is that I forgot to add. So this is the module syntax. So that's something that you might actually run into if you're using some of the examples, is when you're using the module syntax, you don't have to put 3 in front of everything. But when you're using just the regular JavaScript stuff, you have to do this. So inside of my animate function, so I'm not going to have this animation anymore. I'm just going to replace this with controls.update. So this will update the controls every frame along with my animation. So now if I move right and left with the right mouse button, you can see I'm rotating the scene. And because the box is in the middle of the scene, it looks like I'm just rotating the box, but I'm actually rotating the entire scene. If I go up and down, I'm rotating up and down. If I use the right mouse button, I can move the camera left and right. And I can move the camera up and down. And then if I use the scroll wheel again, I can zoom in and zoom out. So it's just like our controls in the editor.